Okay, guys, I'm back. We're going to do some more comparing fractions, and this time we're going to do it more with our computational method rather than doing it with our fractional pieces. So I know before we've done all of we've done a lot of work with our fraction manipulatives, but today what we're going to do is we're actually going to find equivalent fractions by using more of our computation method. So we're going to do this using equivalent fractions. Okay, so when we're doing things with equivalent fractions, we want to try to make the denominators the same so that we can compare them. So one of our first lessons was about trying to compare things with the same denominator. So for example, if I have 3/7 and 6/7, it's going to make it easier to compare these because they're both the same size pieces. I just happen to have more of the sevenths over here with the 6/7 and less over here. So that's going to make 6/7 larger. So let's say that I have 7/12 and 3/4. Okay. Now, if we think about what I typically do, my strategy is to think, okay, I kind of go through my strategies. So number one, do they have the same numerator? No, they don't. Number two, do they have the same denominator? No, they don't. Is one greater than or less than 1/2? And no, they're both more than 1/2. So I'm kind of stuck with all three the methods that we've talked about so far. So now we have to go into equivalent fractions. So for 7/12 and 3/4, 12 and 4, I know that 12 and 4 are they're related to each other because 4 times 3 is 12. So I could make an equivalent fraction of 12. So this one would stay the same, 7/12. Now, same with fractions. If we were doing equivalent fractions here, 4 times 3 would be 12. So 3 times 3 would be 9. So now, because I've done equivalent fractions, I have the same denominator. So now I'm able to look at this and say, okay, 9/12 is larger than 7/12. Okay? So that's one way, that's a way that we can get our equivalent fractions doing that. Let's do another one side by side here. Let's do 2/10 and 1/5. Okay, so we kind of go through our list again. They don't have the same numerator, they don't have the same denominator, and actually both of these are less than 1/2. So now I'm stuck with finding this equivalent fraction. 5 and 10 are equal to, or are related to each other because 5 times 2 is 10. So I'm going to make my denominator 10. So 10 and 10 are the same. So 10 times 1 is 10, 2 times 1 is 2. So I don't have to change that one at all. To make this one happen, 5 times 2 would be 10. So 1 times 2 would be 2. So in this case, 2/10 and 2/10 are going to be equal. So you're going to have opportunities where you're going to have some that are equal to each other. Okay, let's do another one. Okay, so let's try... Let's do 1/2 and 2/6. Okay, denominators are different, numerators are different. So let's try our equivalent fraction mode. I know that 6 and 2 are related to each other because 2 times 3 is 6. So I'm going to make my denominators equal to 6. So this first one doesn't need to change. 2 times 3 is 6. 1 times 3 is 3. So now if I look at this, I can see that 3/6 is larger than 2/6. All right, let's try another one that's kind of tricky. Let's do 2/3 and 3/4. Okay, now all the ones we've done so far, one of the denominators has been able to, you've been able to multiply one denominator by something to get to the other one. You can't do that with this one. So we need to think about multiples of 3 and of 2. So I know that 3 and 4, I'm sorry. I know that 3 times 4 is 12. So I could multiply those two numbers together and get a denominator of 12. So 3 times 4 is 12. 2 times 4 is 8. 4 times 3 is 12. 3 times 3 is 9. So now I can see that 9 twelfths is larger than 8 twelfths. Okay, so that's using equivalent fractions. Now I'm going to show you the way that I think just about everybody loves. I call this the butterfly method. And you'll see why in just a second. So the butterfly method. So let's say I have a fraction like 6/7, and I'm trying to compare it to 5/8. Okay, so again, my numerators are different, my denominators are different. These are actually both more than 1/2. So I could make equivalent fractions, or I could do the butterfly method. So for the butterfly method, what you're going to do is you're going to multiply the 7 times the 5. You're going to go bottom up. So 7 times 5 is 35. And then you're going to go bottom up here. 8 times 6 is 48. And what a lot of people do is they make this a circle and make that a circle. And then you can kind of put a little butterfly right here. So butterfly method. But you're going to go bottom up both times. So 7 times 5 is 35. 8 times 6 would be 48. So then you're looking at which one of these would be larger, 48 or 35. The 48 is larger. So that means that our 6/7 is the larger number. Now let me show you why this works. So here's the why. So if I had 6/7 and 5/8, if I was going to do my equivalent fraction mode, I know that 7 times 6 is 56. So 7 times 8 would be 56. 6 times 8 would be 48. Look at that. 48, 48. They match. Now 8 times 7 is 56. 5 times 7 is, you guessed it, 35. So what we're actually doing here is kind of a shortcut method to making equivalent fractions. Okay, so this is a way I think that a lot of people enjoy doing it because it doesn't involve all of the thought process that happens with this equivalent fractions. But the reason that this works is that you're actually making equivalent fractions. You're just not stating what the denominator is. Okay, so if you multiply the two bottom numbers together, 7 times 8 is 56. So you're really getting a fraction here that's 35/56. And this one is really 48/56. So that's why that works. All right, let's try another one. Let's do 4/7 and 3/6. Okay, so we're going to go bottom up. 7 times 3 is 21. Bottom up, 6 times 4 is 24. So the one here that's larger is 4/7. Okay, so I think a lot of people really enjoy the butterfly method because it's kind of quick and easy. Just the trick is that you have to remember to go bottom up each time. All right, let's try 5/6 and 9/10. Okay, same thing. Bottom up. 6 times 9 is 54. 10 times 5 is 50. So the one that's larger here would be 9/10. Let's try another one. Let's do 5/12 and 6/8. Okay, bottom up again. 12 times 6 is 72. 8 times 5 is 40. So the larger one here is 6/8. Okay, give it a try, guys. Video's over. Head back to Google Classroom. Check out the board notes. and complete the worksheet and the fast check. And feel free to check in on office hours. I'm happy to help out and do some more sample problems. I know that comparing fractions can be tricky, so don't be afraid to ask questions. I'm happy to help. All right, guys, have a good one. Thanks. Bye.